In this video, we are going to move on to the introduction to Panda. For that, I'll go to File, New Workbook Drive, and I'll change this. This is a third session. So session 3. Awesome. So what do we want to do here? We want to look at Panda. So if I want, just to save time, well, I'll just put it. It's okay. Not the end of the world. I'll double click here and simply say introduction to Panda. And what do I want to do under this introduction? I want to look at series and data frame. I will explain what they are, but first let me just do some basic formatting. I'll use 2 hashtags here. I'll use 2 stars at the beginning and 2 stars at the end to make it bold. You can see what happens, and when you do this and you move there, you see that happening there. So here I'll just do Shift Enter, and that is it. So basically we want to start. Before you use Panda, you really need to import the library. So let me just say import library Panda. So Panda is a library that has been written with lots of functions, and it is used basically for data analysis. It's the most used library for manipulating your data. So in order to import it, you simply type import Panda. And so as not to be using Panda all the time, we will say as, and we are going to give it an alias. So we will generally PG is used. So as PG, and you can run it. Basically, I'll just say Shift Enter, and you'll see that it takes a few seconds at the beginning of the when you're opening new notebook, but after that's it. So it has imported it. Let's look at the version. I can simply say print, and as we've been doing, I'll use the F Panda version. Then of course I'll say pg dot underscore version. I'll just hit enter and I'll run it. So we are using version 2.2.2. That's the version that comes with the Google Colab I have. You can choose to update it if you want, but I will not be doing that. Without much ado, I'm going to move immediately to a first thing. So here I will be creating a series from a Python list. Now, why do we need to convert a list into a series? A series is a Panda data type, and it has lots of methods that have been written, or lots of functions that enables you to manipulate the data. So for example, let's create a variable. DL simply means data list. You can use whatever you want. Just make sure it's meaningful. So let's say 10, 20, 30, 40, and 50. So that's basically your data list. Now we want to convert it into a series. So rather than we have a data series. I'll call it DS. So it's no more a data list. So use any naming convention that makes sense to you. Now, how do we convert it? I'll call Panda using PG. Remember, we have given the alias PG, and that is what is always used in industry. PG dot. Now we are going to use series to be able to convert it. Now you start with capital, so it's series, and then you simply enter DL. So you are grabbing this thing inside that, And once we do that, we can now, I can just say GS so that we can see how it looks like. So you can see, well, that's the data. This is how it looks. Now you can see that by default, it gives you an index. The data look like that. When you convert it into a series, it looks like that. So remember, a data list can have whatever you want in it. You can convert that into, let's take for example, fruit that we were using the other time. So I can go back to cherry, mango, banana, okay. So I can convert this into, I'll just say fruit series or S series fruit. For that, it has to be pg dot series and then rabbit in wrap fruits in it, and then let's see sf. So that's basically it. So just before we move on to the next thing, let's just try to print it and see how it looks. So print, if I use print for SF, what do I get? So that's a bit how it looks. It looks a bit different. You see the formatting is different. You don't have this title here. You just have the index starting from 0 to whatever you have. Now we are going to define an index. So basically, I'll just say creating a series with a custom index. So let's just create a custom index and we are going to assign it to whatever we have there. So I'll just say custom index. It's another list. So I'll rather give it A, B, C. Now you see this is just what we have. We have A, B, C. So I'm going to stop there. And when I come, in order to create my series, I'll use the same approach I use here. However, within that, I'm going to enter much more than what we have there. Okay, I'll call this no more. This was SF. So we have fruit. I call that SF, so I'll call this SF1. So we have pg dot series and we had fruit. Now this is where I'm going to enter my custom index. So I'll indicate that index, the index equals custom index. Once you do that, when you're, so I can just do sf1 or I do print sf1. So let me run it. So here we go. So now we have this as the index because I chose to enter a custom index. So you can just put hashtag in front of this and you run it. It's going to print it using the other approach. However, you will have this title, which you never defined. Here we are going to create a series from a Python dictionary. Okay, let's define a dictionary. So I'll just call it dict. Now remember how you create your dictionary. You open the curly braces, and within it, you put key value pairs. So I'm going to create something like a shopping list, how many things I bought when I went to the supermarket, for example. So let's say I have cherry. Let's say I bought 5. Now you always have to use a comma to separate them. Banana. Let's say you bought 4, comma, blueberry. 6 boxes. And let's say you bought apple. You bought 3 bags. And that's the last one. That's it. Now let's convert that. So it's going to be series dic. So it's series dictionary. So we will do pd.series, and we will put dic in it. And once we come here, print sd, and there we go. So we have cherry, banana, and so on. That's it. So now we can use it to do all sorts of manipulations. Now you can see all what we've been doing. There is really no name here. We want to be able to give a name, not just have this, but you also need to know what is here. You know this is, here you have food quantities. You want to be able to do that. So let's just say creating a series with a name. So basically I'll say SD1, and we have pd.series, and within it we have dic. Now that will not be the only parameter we are going to put there. We will have name, and now we can give the name. We will just call it fruit. I'll just put ty for quantity. You can put whatever you want, and then we'll have print sd1, and if you want at the end, you just do sd1 to see the different variations. So here you have name as food quantity, and here when you do not put it within print. So when you do it within print, this is what it happens. It gives you that, it tells you that. However, when you do not put it, this is how it looks. I actually like this much better than releasing it. It's true that when you do this, it gives you the data type that you are dealing with integers, but this also tells you, and I like the look of this much better than when you use print. Now we want to take a look at what we call attributes and some basic methods. This is where things start getting interesting, because whenever you're analyzing data and you have a series, you need to use the attributes, you need to use the different methods to be able to extract information from your series. So let's just say series attributes and basic methods. Now let's just start with, I'm going to start with attributes, but before I go to attributes, let me just create a series. So I'll call this fruit series. And for that, I'll just do pd.series. So So in this case, I am not going to first create a dictionary and then put it in there. Generally, it's good. It's a good practice. However, I'll just wrap it in here to show you another approach of doing basically the same thing. So here I'll say Apple. So I'll put the value pair. Apple. And I'll say 5, comma. Then we will have banana. 4, comma. Then we can go to cherry. 7. We can go to date as a fruit. We can go to 4, comma, and I'll take blueberry. Now go to 6, and then if you want, we can give it name. Actually, I'll put a comma here and then give it a name so that we don't just have the dictionary, we also have the name. So I'll say name equals, we called it food quantity. I'll just say quantity. So I'll call that fruit series. And there we go. This is a fruit series. That's what we will be using for most of the things we'll do now. So let's look at some attributes. Okay, the first attribute we want to take a look at, we want to examine the index. So for example, for fruit, so I can use print, but I'll just choose not to use print. That will make us save time. So I'll just say index. So you will notice that when you are using attributes, you will not put, how do you call it? You will not close it at the end. Okay, when you are using a function, you have to do that. Okay, let me adjust this. This is actually fruit series. Yeah. So you want to find out what the index is. I'll run it, and you can see that this is the index. You have the quantity, and this serves as the index. Okay, now let's look at the next attribute, fruit series dot value. Now it's telling us that, Jean, you've made a mistake. There's nothing like value. There is values. Now another interesting thing, let's run it. And that's what you have here as the values. Okay, let's take a look at the next attribute, fruit series. You always use a dot to call it. You want to know what is the data type. And you can see that the data type, it's an integer. As we move on, you will find that this is extremely important because there are times you want to run an analysis and you have to make sure you are using the right data type. So the next one, fruit series, you want to know the name so that you make sure you use it properly. So the name is quantity. You can see here we have quantity. That's the name we've given it. And the next one, so I've just chosen the ones we generally use. So we want to look at the size of your data. Shift enter. 5 means if you count how many data points do you have, 1 2 3 4 5. So when you are dealing with big data, you'll just find that you have millions of rows. That's the idea behind it. So let's move on to fruit series. Now we want to take a look at shape. Shift enter. You can see that it's just telling you it's one dimensional and it's just 5. That's all what you have. Now, when you start dealing with data frames, when you go to shape, it's going to give you much more than that. So we want to look at the unique values. So for that, we are going to use is unique. Food series is unique, and we run it. So the question you are trying to ask here is, are all the values you have unique? It says all the values are not unique. Why? If you take a look, you'll see that here you have 5, you have 4, 4 appears twice, so it's not unique. If you want to check that, let's say we make this 9. If we run that, we find that here all the values are unique. So if we come here and we run that, it's true, telling us there is no duplicate value, everything is unique. Now let's basically look at the last one, because here you basically see how it goes. We want to look if it has not a number. Okay, we want to see if we are checking for missing values. Do we have missing values? We have no missing values. What do we mean? Let's say we had come here and we had forgotten to insert something, then we would have had a missing value. Now we want to take a look at some basic methods. This is where it really gets interesting. Basic methods. You always need to examine your data using this. I will say the one we are going to look at is basically the one I use the most. When I have any data set, this is the first thing I do. So we have food series dot head. So this will give you as a default the first 5. So 1, 2, 3, 4, 5. Now you can adjust it, for example, and say I only want to see the first, second, and third. So that's it. Now you can also use tail. Food dot tail, and it's going to give you the last 5. So for example, if your data goes from 2000 to 2025, the last 5 is the 2025. But if you are looking for the first ones, so it goes in ascending order. That's just the thing. Your data is generally arranged in ascending order, then it looks for the first or the last one. So let's run this, or you can just say 2. If you do 2, you will see that we are going to have just the last 2. That's it. Okay, let's move on. We want to run some basic statistical analysis here. We will use describe. So fruit series dot describe, and you will find that when we are now using methods, you always have to use your brackets, always. So when we run it, this is how it looks like. Now we can transpose it if we want it to look more. So from time to time, I will just transpose it. Describe. It means I come here and I use a T, and then when I run it, let me see. So in this case, transpose does not yield anything special, but once we take a look at data frames, when you use it, it flips it and it looks really, really interesting. It doesn't yield that because it's just a one-dimensional thing here. However, just good to know that in data frames you can use it. Now, if you take a look here, you have all sorts of these things being computed. What happens if you have categorical data? If you just have categories. So let's take, for example, cat series, where we are dealing with categorical data. We want to do the same pg.series and Well, I think I'll just use a series here. I'll use a list here. So a list of animals, dog, let's a dog a second time. Okay, I can I can leave it at that. And I'll just put a third cat. And cat series. Well, let me print it. Let's see, print cat series. This is how it looks like. So what if we run cat series dot describe? There we go. So here you can see count, unique cat, frequency, and so on. So you see the top thing is cat. How many times does cat occur? How many unique values do we have? If you look, we have 3 unique values here. We only have cat, dog, and mouse. There's no other animal. So we have 3. The total of objects, we have 6. What is the score with the highest frequency or the mode? It's cat. And how often does it occur? That's it. So it's quite different from what you get when you are dealing with numerical data. So let's run some more things. So here, for example, cat series, you can so we are going to use unique. This is something I use very often. So you want to see the unique values. That's it. The value, the unique things which are present in that data set. Those are the things. So let's try this. Not fruit, cat series dot, I'll say n unique. And you can see it has, so n unique. So here you have unique, you can see the unique ones. Now if you have to count how many of them are, you just put n unique and it's going to give you the number of unique values which are there. Now we will use another approach. I'll use fruit series, and this time I'm going to use value counts. If you run that, you will see the different values, they occur, how many times do they occur. And I'll run the same thing for cat series, and I'll say value count, and then you can see the number of times it appears. So this just helps you to better understand your data. At times you can graphically represent that to see how it looks.